All right, everyone. This is Cameron Smith from TechLogix here today to go through some more information on fiber optics. If you joined us a week or so back, I appreciate you coming and taking our Fiber 101 class. Today, what we'll be looking at is how we can really position the optical category for builders. And today's session is very heavy on the residential market, though what we'll be covering is really relevant whether you're doing security, commercial, there's a whole lot of different applications and industries that are using fiber now. And the nice thing about the cable is you can really use it anywhere. But what we're seeing, really literally worldwide, we're a US-based organization, but what you're finding is fiber is being used in residential projects at an increasing rate, especially with folks who are working remotely. Faster internet speeds are required. More people are streaming their television and their video subscriptions. So we're finding that you need a cable that's going to support a higher level of bandwidth. Now, a couple of things before we get started. We do have about 45 minutes worth of content here. If you do have questions, please type those in. The answers to those questions might be coming in some forthcoming slides. We'll make sure that all the questions get answered, but it may be at the end of the session. Second thing, we know that this is a primer, and we also know that fiber is a relatively new topic to most integrators. Definitely use us. Use us to help you answer questions. Use us to do designs. It's really not that difficult of a product category, though it's different, and we're here to help you work through that. Now, let's begin today's session by really discussing whether fiber is necessary, because I'll tell you that we do a lot of sessions here at TechLogix. I mean, we over a dozen different training sessions that are just focused on fiber optics. And often we will get asked the question, is fiber really necessary? Because frankly, people have been pulling twisted pair, Cat 5, Cat 6, Cat 7. It's worked great, and it does everything we needed to do up until, now. So can we ask the question, is fiber necessary? And how do we position that when we're looking at all these different cable infrastructures? Well, let's look at those cable infrastructures, and let's really understand what the cables we've been working with for the last, decade plus can handle. And let's start by discussing standard twisted pair cables. So this is Cat 5, right? We've all worked with Cat 5. We've installed this. We've put this in the wall for 10, almost 20 years now. And standard twisted pair cable has done its job admirably. What we find with these formats is you've got about 100 megabit max bandwidth. You've got about 100 meter max distance, so 330 feet. And this is a cable that's really designed for communications. There's no shielding involved. That's what makes it a standard twisted pair cable. And these are usually thought of for things like audio and networking. But we didn't really use standard twisted pair for that much video, and that's because the lack of shielding makes it really susceptible to interference. When we talk about video and twisted pair, this is where we get into the enhanced twisted pair cables. These have shielding involved in them in most cases. Not all the time, but in most cases. That shielding, coupled with a tighter twist ratio, will drive the bandwidth on an enhanced twisted pair cable up pretty significantly. And what you find is you will get anywhere from 1 to 10 gig in bandwidth. Now, there's a couple of things that you really got to understand here, though, because when you look at a spec sheet, regardless of manufacturer, you're not necessarily going to see a guaranteed bandwidth at a guaranteed distance. That's a problem with twisted pair cables because these cables are susceptible to interference. And what you'll find is any cable that has a 10 gig rating is usually going to max out at about 37 meters. Okay, and that's because when you start to get into interference and all kinds of different environmental issues, it'll drive that bandwidth down. 1 gig is usually where these cables can really perform well, and that's usually across the entire spec of the cable, so 100 meters. This is kind of your max network length. But again, these have worked well. 1 gig, it's a pretty good amount of bandwidth, and historically, that's what we've needed for installations, especially when you're getting into video. Now, let's compare this to fiber, okay? Because fiber is the new kid on the block. Keep in mind, it's not a new technology. Fiber's been around for over 50 years, but we're only now starting to see it find its way into AV and security and networking type applications, at least as our industry uses it, right? Fiber historically was that telecom cable, that broadcast cable. Well, today we're putting it in the wall. And the nice thing about fiber is we don't have to worry about shielding. It's completely immune to interference. We don't have to worry about electrical issues. It's completely immune to static and surges and lightning, all kinds of issues that we traditionally see with a copper-based cable. But what we also find with fiber is we can go really long distances, which, yeah, granted, in a residential application isn't necessarily that much of a requirement. You know, maybe if we're connecting buildings, outbuildings, maybe if we've got a really large property, but where fiber shines is in bandwidth, okay? We do not have a problem sending 10 gig over an optical cable. In fact, we don't have a problem sending 40 gig or 100 gig or even 100 petagigs worth of data. If you've taken other classes that we teach, you might have seen this statistic, right? When you actually look at an optical cable, one of these modern optical cables, it actually has the capacity to push over 100 petagigs. And for reference, that's 10,000 times more bandwidth than Cat7. Now that's the cable. Keep in mind, that's the cable, not the electronics. The electronics are the weak link here. But these cables, they've got all the bandwidth capacity that you need. Now, what about Cat8, okay? Because we're getting more conversation, more questions around Cat8. And frankly, this is an area that a lot of integrators are starting to move toward. And the big reason is because, yes, there's a perception that we get more bandwidth out of it. And there's a comfort factor, right? We know how to terminate twisted pair. So if I can get another twisted pair cable that can push that bandwidth up more, great, I'm going to go for it. Well, here's what we find in reality. First of all, just like other twisted pair cables, you can't guarantee a bandwidth over a certain distance. And that's because of the environment, right? Depending on the environment, we may have interference, we may have issues that will drive that bandwidth down. What you do see with Cat8 is usually a 2 gig rating up to 30 meters, okay? A little bit variable, as I mentioned. You do get 40 gig, okay? That's a lot of bandwidth, 40 gig over short distances, and usually that's 3 meters or less. So we're talking about patch cords in this type of conversation here. But here's where the Cat8 conversation starts to get a little clunky, okay? And literally clunky. It's a big cable. It's a significantly big cable, okay? About a 1/2 inch diameter, 6-point-inch minimum bend radius, 25-pound pull rating. And then we start to talk about the weight. I mean, a spool of 1,000 feet, 300 meters of this cable, I mean, you're dealing with anywhere from 45 to 60 pounds. So it's a heavy cable. There's a lot of shielding that goes on, and you pay for that. You know, that construction costs money. And here in the United States, we see that these cables are about 65 cents per foot on average, okay? But the connectors are also where you're spending money, about $15 per connector, okay? That's U.S. prices, granted. That's U.S. prices. Punchline here is, yeah, Cat8 will increase your bandwidth, but it's not the easiest cable to pull, to work with, to navigate. And as you'll see here in a minute, that 40 gig spec over short distances, that 2 gig spec over 30 meters, that might not give you enough bandwidth to really get the job done. So let's turn the conversation over to bandwidth. And there's a couple of things that we want to make sure that we're on the same page with. There's 2 types of bandwidth, 2 different ways we look at this in the AV industry. Video bandwidth, so this is like the size of your video signal that goes from your source device to your display, okay? That's bandwidth right there, okay? How big is the video signal? What's it take to get that signal from point A to point B? Now, the other way we look at bandwidth is streaming bandwidth, our internet, right? What's it take to get the internet signal, the network signal from point A to point B? These are very different because video doesn't have packet correction, okay? Video actually drives a higher bandwidth than streaming network, okay? That has the benefit of compression and packetization and packet correction. So 2 very different ways we talk about bandwidth. Let's look at both separately, okay? Let's start with the network. Here's what we're seeing with networks, okay? And this is a big reason why builders are starting to warm up to fiber because their customers, the people who are buying the houses, buying the properties, the condos, the apartment buildings, well, they have more streaming devices now. They have more network connected devices. And what we're starting to find is as those devices incorporate video, they require faster speeds. They require more bandwidth to work properly, okay? And you've seen a proliferation in the amount of connected devices in the average property. So when we look at what is the average consumer doing, okay, how many devices do they have? Well, we've seen the number on average double over the last 2 years. And nobody thinks that this is going to slow down. Nobody thinks we're going to have less connected devices, that we're going to move away from smart TVs and media players and smart lighting systems and smart thermostats. That's not going to happen. It's only going to continue to accelerate. And we can take those devices and we can put those into 3 groups: low bandwidth devices, moderate bandwidth devices, and high bandwidth devices. And this is really important, okay? Because this allows us to start to quantify how much bandwidth is required to make the system work. At what point does the cable no longer handle the amount of traffic we're trying to send? At what point does our network switch not work, right? There comes a point at which we max out, and we can quantify how many devices, what those devices are, and we can start to do the math and say, all right, am I pulling the right cable? Does this application, does this building have the right cable, the right network installed? Well, let's do some math, okay? Let's start with low bandwidth devices. These are your controllers. These are your Apple Watches. These are the different devices that don't really move a lot of audio, don't move any video. They just toggle the network. They hit the network, they hit the internet, they send some commands back and forth. They don't use a lot of bandwidth, okay? On average, the minimum required connection is 0.2 meg. That's not a lot, okay? Now keep in mind, that's per concurrent connection. So yes, I don't need a lot of speed when I have, you know, one smart thermostat on my wall, but now when I put on my lighting controllers, each one separately toggling that network, and now when I put in my sprinkler system and my shades, and I start to put all these different connected devices, it adds up, okay? 0.2 meg per concurrent connection. But then we start to talk about audio and video, okay? Here comes audio, streaming audio players, phones. You know, if anybody on this call today, this webinar today is working with the commercial world and you're doing an office building, you know that there comes a point at which a lot of IP phones require a pretty strong backbone, okay? What do we find with IP phones? Well, on average, the minimum required connection is 1 megabit per phone, okay? Now, granted, will some phones be used all the time? If I have a call center, for example, will all 100 people there be on the phone at the same time? Maybe, maybe not, but we got a plan for it, right? So as we start to look at audio incorporated into the project, we start to find that those standard twisted pair cables, they really can't handle what we're asking of them. But here's the good news, right? You're probably not pulling standard twisted pair anymore. You're probably pulling enhanced twisted pair, okay? Those are the gig cables, as we just looked at. But when we start to incorporate video into the conversation, now we start to see things really add up, okay? And I know you've seen this, guaranteed, right? You're doing more video over the network. You're doing more streaming devices. This is a real part of what we do today. And when we incorporate video into the conversation, things like video doorbells, things like security cameras, what do we find? Well, that requirement goes up to 2 meg per concurrent connection. And keep in mind, this is standard def video. We're not in the HD world yet, standard def. Granted, are you going to put in 1 security camera? No, you're probably going to put in 4, maybe 8, maybe more. You know, how many video doorbells are you going to have? How many different video streaming devices are you going to have? Well, it starts to add up more aggressively. But it's when we get into the HD world, it's when we start to look at things like 1080p, 5 meg, 4K, 25 meg, 8K, 60 meg per concurrent connection, then now all of a sudden we're starting to do the math. We're starting to add up all those connected devices and, you know, the average homeowner, and we find, well, they've got 50 connected devices. What are they? Well, let's add it all up, and oh, wait a minute, I'm at, you know, 300 meg, 400 meg, 500 meg, whatever the number is. What's my path for upgrade? What happens when all those 1080p displays, those 1080p media players decide to go 4K, 8K, 12K? What happens? Do I have a cable that can handle that? Because here's the thing, right? It's easy to replace a network switch. Pop it out, pop in a new one. It's not so easy to pull new cable. And this is why you're starting to see fiber really getting bundled into projects. Because as we start to do the math for networking, we see on the horizon we're going to be out of bandwidth here pretty quick. It's adding up. And then we start to see some other trends, consumer trends like esports, video gaming, you know, people working remotely where they're televideo conferencing in, you know, doing webinars like what we're doing today. This all takes video. This takes traffic. This takes interaction, and that bandwidth is only increasing. So keep in mind, this is streaming bandwidth, okay? This is very different than video bandwidth. We'll talk about that here in a minute, but before we go there, I do want to let you know that we have resources that can help you quantify this. We're happy to share these slides. So if you want to email us, if you want to email your friends at Elan, you can certainly do that. We'll get you these resources. Or I'm sorry, we'll get you the slide deck, but we also have handy one-page PDFs that will allow you to go through the project and actually do the math and quantify, do you have enough bandwidth in this project and what's your upgrade path? But now let's turn the conversation over to point-to-point video, okay? Very different. What we were talking about up until now is the network, packetized communication of transmission signals, okay? This is your video signal that's ones and zeros finding its way into the property, okay? You actually don't need that much bandwidth. You might look at 60 meg as a high number for 8K, but it's actually not that bad because you have a degree of latency, you have a degree of packetization on that signal. It's when it gets into the property, when it gets into the media player or the PC or whatever your video source is and it gets put together. Well, this is where you start to see the bandwidth really accelerate because now we don't have the luxury of packet correction. Now we don't have the luxury of compression per se. The video signal's been put together and now you got to do something with it, okay? So let's look at the bandwidth that's required for that. Very separate conversation. 4K, I know most of you, everybody on the webinar today, we're dealing with 4K. That is becoming the standard in the industry. It used to be 720p and then 1080p. Well, today we're in the 4K world. Well, 4K is interesting because 4K is the first time that we've really seen the bandwidth of our video signals exceed what twisted pair cables can do. And we can quantify this, and I'm sure you've seen this number before, 18 gig, okay? 4K 60, 444, HDR, multi-channel audio. Well, if you put it all together, it drives the bandwidth of that signal up to 18 gig. Well, let's go back to our previous slides, and let's talk about those twisted pair cables, right? You might remember that standard twisted pair, that's 100 meg cable. You can't even use that to send high definition video. Won't work, okay? Won't work. When you get shielding and you get into the enhanced twisted pair cables, well, what are those? Those are 1 gig, maybe 10 gig, you know, in a perfect environment over shorter distances. Well, even that's not going to work. We're dealing with 18 gig here, okay? And then we kick it all the way up to Cat 8, okay, 2 gig. Not in the same ballpark as our 18 gig signal. This is where we're starting to see an issue. Okay, we're exceeding what these cables can handle. Now, keep in mind, all right, let's take a time out because I am not telling you, this is not to say that we can't take 4K over twisted pair. You can. We do it every day. We do it with AV over IP devices. We do it with HD-based T extenders. But we don't do it natively. We're actually taking that 4K signal and we're compressing it. We're taking the 444 part of it, the color space, and we're compressing it down to 420. That's how we do it. Now, that comes with, you know, some problems. It gives us some latency. Though the manufacturer, you know, a lot of us will tell you that's not perceivable. It's got, as long as it's under 30 milliseconds, you're not going to be able to perceive it. But there's latency. Bigger issue is there's color banding. Okay, when you destroy the color space, compress it down, and then blow it back up, you will see color banding in your image. Now, in the residential world, it's hard to tell because it's moving picture, but you can tell the difference. It is perceivable. And when you've got customers that are spending a lot of money for systems and you're compressing it, you're not necessarily doing them justice, but it is possible. And then we talk about 8K. So all of a sudden that 18 gig bandwidth now is being pushed up to 48 gig bandwidth. That unfortunately is too big to compress onto twisted pair. Doesn't matter if you have Cat 8 over any significant distance, it's not going to do this, okay? You're dealing with 300-to-1 compression algorithms. Doesn't work. So as we start to talk about what's my path to 8K, am I going to have an 8K projector? Am I going to have an 8K display? Am I going to have an 8K media player? What am I going to do here? I need to have fiber. I need to have fiber for that video run, much less, you know, the network. Yeah, the network's going to need fiber for speed and bandwidth and all kinds of other reasons. But the video feed, that video cable has to be fiber-based. Because I got to push the bandwidth up to 48 gig to make this work. And this is where you're starting to see a lot of moving parts in the industry. Because now we're seeing 8K displays, we're seeing 8K projectors, we have 8K content, we're downloading it, which speaks to another trend we're seeing worldwide, right? Our consumers are streaming their audio and their video, and 8K is designed for that, the first broadcast standard that's actually designed for streaming. So it's a really an interesting conversation, and it's one that a lot of integrators aren't aware of, because as we keep on pushing into Cat 7 and Cat 8 and whatever comes next, Cat 10, I don't know, right? The industry is going to keep pushing in these directions. The reality is copper-based cables have issues. You're hitting the max capacity of what they can do. It's time that we look at optics. So we can take all these applications, okay? We can actually break them down by gig, and we can say, what works? Well, let's go back to our standard twisted pair cable. If you're going to live forever in the 1080p world, all right, you're going to compress your signal, you're going to get it over standard twisted pair. If you're going to get into anything with 4K, all right, now we're going to talk about enhanced twisted pair cable. We're going to compress those signals. That's how we do it. We compress those signals. But if we're looking for true native video, if we're looking to ever evolve into 8K, you have to pull that fiber optic cable. We just don't have a choice. It has to be a fiber optic cable, okay? And then if we start to talk about, well, let's switch the conversation over to the network, what works here? Well, there's two different ways we can look at it. Are you streaming video? Are you streaming 4K? Are you streaming 8K? Are we extending it, you know, from the video source? How many different connected devices? Yes, a lot of variables. This is where you're going to want to get that one page, you know, little quick worksheet that we created that'll let you quantify bandwidth. But the reality is, if at any point you are doing an installation that will migrate beyond 4K, if you are doing an installation that follows the trend of our consumers with more streaming devices, well, now we have to be thinking about fiber. And as you're pulling these cables, you got to think about this. You got to think about, how am I future-proofing this installation? Because the reality is trends continue to push in this direction. So now it leads us to the second part of this webinar. Okay, how do we integrate this? How do we move our businesses from the copper world into the optical world? Because I'll tell you, there's a big reason why the classes we teach for CEDIA and BIXI and, you know, the different industry groups that TechLogix works with, there's a reason people take these. It's It's because they're new to fiber. They've never done it before. They're curious about the technology. They know they need to move their businesses in these directions, but they don't quite know how to do it. And they always ask the question, well, where do I get started? How do I do this? Well, let's, again, go back to how deployable are these cables, okay? Well, here are some of the statistics that we were talking about with twisted pair, okay, shielded twisted pair. We saw before the big cable, the heavy cable, 44 pounds on average. You get your bend radiuses, you get your pull strength of 25 pounds. We can actually compare this to fiber, okay? That same little optical cable that gives you all kinds of bandwidth, future-proofing. Look at this, significantly smaller, half the size of shielded twisted pair. I mean, a quarter of the weight, right? 13 pounds for 1,000 feet. It's a very, very small and light cable. But it's when we get into the handling, 220-pound pull strength, less than a third of an inch, 7.5 millimeter bend radiuses. This is why you're seeing optics starting to find their way into these projects. It's incredibly deployable. It's actually easier to pull and easier to work with than what we find with enhanced twisted pair cables. But here's one of the things that really starts to get attention. And if you took the class a couple weeks back, you probably remember something about the pricing, because I will tell you that this is what gets most people's attention. The fact that we have seen the cost of these cables come down so much. I mean, people can appreciate the fact that, yeah, it's small, it's really durable, right? It's not the old fiber that people think of that it's going to shatter, it's going to break, it's going to be hard to work with. No, fiber, the whole category, it's matured. It's become very easy to work with. But it's the cost that really gets people's attention now. We're talking here in the United States, 20 cents a foot, okay? 20 cents a foot. If we compare that to what we're paying for Cat 6A, Cat 7, certainly Cat 8, we find it's significantly less expensive. The fiber that we're using for most prewires, regardless if you're doing residential, commercial, data, doesn't matter. Same cable, pull it wherever you want. Doing audio, doing video, doing USB, doing network, doesn't matter. This cable does everything, okay? It handles all these signals, with one exception, doesn't transmit power, okay? Keep in mind, fiber, there is no power transmission, but beyond that, it does pretty much everything, okay? All the different signals, really easy to work with, 20 cents a foot. So folks are starting to bundle this now with the other low voltage cables you've been pulling. You can pre-wire for video expansion in the future, for the increased resolutions that we're going to be working with. Put the fiber cable in the pole. What's it really cost to future-proof of the host that you're working on, the building that you're working on? 1,000 feet, $200 bucks. $200 you just future-proof that building. You might not even use it today. And here's the reality: most fiber that is being deployed is not being used. Okay, it is purely a pre-wire conversation today. And you can use it. There are electronics. We'll talk about that here in a minute. And that is actually one of the big drivers of this category. The fact that you have things to plug into the fiber now. The fact that you can integrate your fiber with twisted pair, like, security cameras that have an RJ45 port, things like that. We'll talk about all that here in a minute. But most fiber, honestly, based on the price, based on how it's built, is being pulled dark, meaning it is being pre-wired. It is not even being terminated. It is being pulled for future expansion, future bandwidth, future video resolutions, okay? And the most popular fiber that you are now seeing in AV projects is single mode. I will explain the differences between the different fibers here in a minute, but before we move there, I want to show you the construction that is really moving the AV industry forward, because this is, as you can attest to, right? It's nice to have one cable that can do everything. It can be used for audio, video, network. It can be used for telecom and ISP wiring, your DMARC wiring, but it can also go anywhere. So whether we're talking about low smoke, zero halogen, or plenum ratings, or outdoor waterproof ratings, these cables are constructed to do all of that with a single cable. and it's 20 cents per foot. Okay, so let's change the conversation now over to the actual applications. Where are we seeing this pulled? When we talk about pre-wiring, where am I pulling it? What am I doing with it? Okay, what are the different runs? What are the different applications? What do they look like? Well, before we answer that question, we have to make sure that you're comfortable with the two different types of fiber, single mode and multi-mode, because there are two different types of fiber, and they're very different. Okay. Now, from the outside, usually they're just color coded, so you can't really tell what you're working with. But on the inside, the difference is the size of the glass. Single mode fiber, so the yellow one that you're seeing on the screen right now, that is the small core of glass, very small. In fact, the diameter of a human hair, 9 microns. We measure fiber cores in microns. Very small core. Multi-mode has a 5 times larger core, the 50 micron core, okay? Significantly larger. Now, this is a little counterintuitive to a lot of AV folks, okay? The fiber that has the small core, single mode, is actually the cable that goes the long distance and supports the high bandwidths, okay? And the reason I say that's counterintuitive, I mean, think about it, right? When we want to take a copper cable and we want to go further or handle more bandwidth, how do we do it? Well, we put more copper into it. In the fiber world, it's the opposite. The smaller the core, the better the light waves propagate. They basically stay in phase better. And this is why single mode, the yellow cable with a really small core, this is why it goes really long distance, I mean miles, thousands of miles. This is a cable we use between continents, okay? Between cities, between buildings. Single mode is that cable. But we also use it in pre-wire because you can use that same cable and you can put it in the wall. And it's going to go really far and it's going to support a really high bandwidth because those signals, those lasers, the optical waves, they're in phase. They stay in phase. The other cool thing is single mode costs less. The cable costs less. Less glass means less expensive, okay? Less expensive to manufacture, less raw material. So what we find is single mode is really becoming that universal cable for a lot of different reasons. Now, multi-mode, bigger core, more expensive, more glass goes into it. But the argument to use a multi-mode cable is that it's easier to handle. A bigger core means that it's easier to work with. So if you're terminating a bunch of these cables in the field, multi-mode's a good choice for that. Though you can certainly terminate single mode. I mean, people do every day. It's just a little bit more delicate of a process. Multi-mode also, while the cable's more expensive, the electronics are less expensive because we can build our electronics to A, have bigger optical lenses, which are easier to manufacture, but the signaling, having multiple modes of communication makes the signaling easier to do, and therefore the electronics cost is less. Now, people, you know, at the end of the day will ask me, well, which cable should I pull, right? Give me one. I don't want to have both. I want one. And the answer to that is single mode is becoming the predominant cable because it's kind of that do all, go anywhere. And my advice to folks is, look, it's going to take you an extra 15 seconds to terminate, but it's the same tools, same type of connectors. It's not like you're tooling up differently, right? You're just going to be a little bit more careful during the termination process, and you're going to get a hang of it and you're going to be able to do it. But certainly in the AV industry, most people are more familiar with multi-mode because it has had more electronics. It is bigger. It is easier to handle. That's just where the experience is. And honestly, multi-mode's a great cable as long as you're not extending or exceeding about 300 meters or 1,000 feet, okay? Multi-mode's a great cable too. You're just going to pay a little bit more for it, all right? So with that said, now we have to understand if we are using our cable, we are using our fiber, what kind of connectors are we putting on it? And there, over the years, have been a lot of different fiber optic connectors. The good news here is there's really only two that are widely used in modern projects and in modern electronics, LC and SC style connectors. If you do go into a retrofit and you do find barrel connectors like the ST or FDFC, for example, those are going to be predominantly the main ones you'll see in older projects. If it's not an LC or an SC, you can adapt them. okay? These all have the same performance. They all have the same bandwidth, okay? They use the same tools to work with. But today, as we build our electronics, LC and SC are going to be the big ones. LC is the one we use in networking in most video distribution, okay? And we're using the LC connector because it's really small. Technically, LC stands for Lucent Connector because there's a Lucent patent on it, and it actually drives the cost up a little bit. But a lot of people call it the little connector, and that's an easy way to remember. It's a very small one, and we use it in electronics manufacturing because we can build our circuit boards more compactly. We can build those extenders, those network switches, those SFP modules. If you've ever seen a fiber switch, you know, with that port on there, you know that you've got two connections side by side on that little tiny port. Well, the LC connector allows you to do that. They're actually half the size of the SC style connector, the subscriber connector. Some people call it the standard connector, okay? This one's bigger. It's a little bit easier to handle just based on the size alone, okay? It's kind of like that multi-mode, single mode conversation. Well, the single mode, smaller core size, a little bit harder to prep for installation. Same thing with the LC connector. It's just a smaller connector, so it's a little bit harder to handle in your hands, okay? SC connectors, they're bigger. They cost less because I don't have that Lucent patent involved. And this is the connector that we used to see on some electronics, but most manufacturers have gravitated away from it. This is the one that we see in a lot of DMARC wiring, telecom wiring. If you're putting a box on the outside of the building, odds are it's going to have an SC connector on it. And we'll even build these in two different configurations. A straight or a what we would call a polished connector. It's basically a straight through. It takes the laser, the light, and goes straight through. Or an angled connector. We call those APC connectors. It really depends on what's your application, what are your electronics looking for. But SC connectors are what we use in this DMARC telecom world in most cases. So now that we've talked about the cable and the connectors, let's talk about the actual applications, okay? DMARC wiring is going to be the big one. This is where we're bringing the fiber feed, the service feed, into the property. And this is something that's happening worldwide because, you know, as we look at the internet, as we look at the length of signals and just our infrastructures, it's actually less expensive to go to a fiber optic infrastructure. And the telecoms around the world, they're doing this, okay? Fiber is moving into the properties. And if it's not happening today, it's not happening now, it will, it's coming. And you can prepare a project to have that fiber feed by putting a box on the outside of the property, okay? A DMARC box, a demarcation box. You can do this. This is something we work with day in and day out. Here's the thing. You got to make sure you're pulling the right type of fiber. And this is a problem that we see in a lot of installations. People think that fiber is fiber, glass is glass. That's not the case. Remember, single mode versus multi-mode. There's a reason we talk through this. Single mode fiber, that's your long distance cable. That's your small core size. And you have to pull the right type of fiber if you're connecting to the service feed, the telecom, the ISP, call it what you will, but the cable that comes into the property is going to be single mode fiber. And if you're pulling fiber to the box to meet it, to couple it, to splice into it, it's got to be single mode fiber. Any cable before the modem has to be single mode fiber. Pull single mode, you're in good shape. Now, once you get past the modem, you do whatever you want. It can be single mode, it can be multi-mode, it can be twisted pair, okay? You have options. But if it's before the modem, it's got to be single mode fiber. Now, once we get beyond that DMARC, the next really common application we're seeing, right, is wiring the network. We're getting this network ready for video distribution. So how do I do that? What kind of fiber am I pulling? What kind of connectors am I putting on this cable? Well, again, as I mentioned, it can be single mode, it can be multi-mode. You want to make sure, though, that that cable is two-strand. You might see this in the notes here. Two-strand, or what we will call duplex in the fiber optic world. That's important. Now, when you're wiring a DMARC, you don't always use two pieces of glass. Often you will use one piece of glass. I still never recommend people pull simplex or one strand of glass. Never. And the reason is the minority of electronics out there, very few electronics use simplex connections. Most use two pieces of glass, duplex or two strand. Okay, that's how we build our electronics as a standard in the electronics world. So if you want to create future compatibility, you want to make sure that your cable run works with everything, pull two strand, pull duplex. That's what you should be focused on. And once we get past that modem, you know, now we're in the networking world, now we're in the video world, now we're talking about that little connector, the LC style connector. So what's this application look like? Well, here's our demarc again. We're bringing that service feed into the property. We're going into that modem. Now, once we get past that modem, you pull what you want, twisted pair, you know, fiber, single mode, multi-mode, and we go into those network switches. And now from that network switch, we can branch that fiber off into the different zones of the house, zones of the building. And this is where you're starting to get into things like rack trays and that centralized rack to manage the distribution of all my fiber runs, wall plates, out in the rooms. This is a big part of the installation, right? Keystone wall plates, I'm going to install those in the different nodes. This is how we're wiring the network. And at the end of these runs, we'll have access points. We'll have other network switches. We'll have all kinds of different devices that connect to our topology. Now, video wiring, this is where we see really the high bandwidth, right, as we discussed, 18 gig, 48 gig. This is another big place that we see fiber being used. We have to be using fiber here. A lot of bandwidth, okay? Different than the network, we're talking about point-to-point video wiring here. Well, here's the good news. I'm gonna make it easy. The same cable that you pulled for the network, the same connectors you put on the end of your cable, you do this exact same thing for video distribution. Duplex, single mode, or multi-mode with LC connectors, okay? Easy. You're really pulling one cable that does everything. And in this application, you're going to be using extenders, okay? Just like the twisted pair extenders, the HD-based T extenders we've been using for years, you have fiber extenders that do these things, okay? We plug these into our LC terminated cable, and now we're pushing that 18 gig, that 48 gig, whatever the chip is. And see, that this is the weak link in video extenders, fiber optic video extenders, or really any extender technology right now. It's not that they can't handle the bandwidth. You know, fiber's got all the bandwidth. We're perfect right there, no problem. It's the HDMI chip. What does the chip allow us to do? And right now, the reality is the world is still looking at 4K chips. You're not seeing the 8K chips that's standard in mass production yet. You will. It's coming fast. We've had a little bit of disruption this year, obviously, with the state of the economies and, you know, COVID and all kinds of things like that, right? There's been disruptions, we get it. But you will see more 8K, HDMI 2.1, 2.2 display port. Actually, the 12K and the 16K display port VISA resolutions have already been released going into production this summer. So you are seeing more extenders that can support those video resolutions. It's not a fiber conversation. It's actually what chip do you put in the devices. Now, there are a couple of things that I do want to mention about extenders. Fiber optic extenders, HDMI, DVI, you know, whatever version you're buying, variation you're buying. You can make these very small. This is an optical-based technology. It doesn't have the same heat output that you see in electrical-based technologies. And this is one of the nice things about fiber. You can build these compact little extenders, compact little devices that hide incredibly well behind flat panels that go very long distances that handle a lot of bandwidth, okay? So this is part of how these technologies are being developed. The other nice thing is manufacturers, TechLogix included, are really specifically trying to build these boxes so they look just like HD-based T extenders. You wire the system in the same way. They're very familiar to folks. This is another thing that is happening out there. We're building the boxes in this way. So keep in mind, you have things to plug into this fiber, okay? Security wiring, this is another thing that you're seeing in a lot of applications. You know, what am I doing with the cameras? What am I doing to give access control and monitoring to this project? Good news here is it's the same cable you are pulling for the network and for the video. Duplex, 2-strand single mode or multi-mode LC connectors. And again, it's really your choice, whether it's single mode or multi-mode fiber. What's your distance? What do you want to work with? A lot of people buy pre-terminated cables, so it doesn't even really matter. You get a cable, you just pull it and plug it in. You have those options too. You might have walked through that option in a previous training that we've done. But here we go. If we look at the real world application for a lot of security, what do we find? Well, we find that yes, fiber is being used for these longer feeds. It's being used because I want to pull a cable that's future-proof. But interesting thing in a lot of these security applications, and the reality is in a lot of network-based applications, you're finding the need to convert from twisted pair to fiber. Because the reality is most electronics, source devices, destination devices, they still have RJ45 ports. They don't have fiber optic ports yet. And especially in a lot of these monitoring applications, we have to put a media converter in. What a media converter does is it takes the electrical signal and it converts it to an optical signal and vice versa, okay? They convert media. And by doing so, we can now take those electronics that maybe we bought a year ago that are really designed for RJ45, and we can drop them onto the fiber cable. And when we do that, we get to go, really long distances. And now we have a cable that has the bandwidth to, be upgraded to something else in the future. It's waterproof, tons of advantages as we've discussed. So media converters are not expensive. In fact, these are going to be one of the lowest cost electronics you're going to put in any project. These things are not expensive. And they really serve an important role because now we can bridge these two different infrastructures, these two different worlds, the optical world and the electrical world together. So know that these exist. You will use these on projects. Okay. Really two other things that I want to touch on in terms of applications here, and then we'll take some questions, make sure everybody's on the same page. Remote building connectivity. Yeah, it's not necessarily a traditional pre-wire type application. In that, when we talk about true pre-wiring, we're usually talking about, hey, I'm gonna wire the house, the apartment, whatever it may be. But hey, if we're getting into outbuildings, we're connecting two buildings together, fiber's used for that. Anytime that we're trying to take a signal, a networking signal and go more than 330 feet. I know a lot of people try to get Wi-Fi extenders, but you also know that those can be really iffy. They can be really dicey depending on the environment. Well, fiber doesn't have any of those issues. And we can use that, that single mode, pull 2 strands, make sure it's duplex, right? Duplex fiber, put LC connectors. Now we're extending those two buildings or connecting those two buildings together. And it's something that I know is near and dear to, most of the people on this webinar, power immunity, okay? How do I pull a cable line that's going to be immune to lightning, surges, problems like that? Well, fiber's immune to that. And that's why here in the United States, we use it in places like Florida, in the Southwest, where we have a lot of electrical issues. Fiber is completely immune to that. So as you wire your infrastructure, you're creating protection for those issues. So let's wrap up here. Let's talk about why fiber. Why are we doing this? Why are we using this in builder projects? Well, it's a very easy cable to use. The reality is the way the evolution of this technology has gone, it's strong, it's durable, it's very pliable. You can terminate this in really the same amount of time required to do a shielded twisted pair cable, and it actually costs less than most of these cables. So we're seeing that from just an installation standpoint, fiber makes a lot of sense. But then when we start to talk about the homeowners, when we start to talk about the builders and what's my property value? Yes, fiber is delivering there. When we talk about the smart home, future-proofing, yes, fiber is delivering there. But some of the very interesting things that I've found is fiber is becoming much more marketable to the consumers. And it's not even what we're doing as the AV industry, it's that the telecom world, the ISP providers, they are marketing fiber pretty heavily because this is a new way for them to create more capital and more revenue. So this whole category is getting a lot of traction now. It just takes a little bit of education, a little bit of learning. And I'll tell you, we have a lot of those materials for you. So don't be afraid of terminating. Don't be afraid of design work. Don't be afraid of, continuing to learn about this topic. we have resources that can help you. They are all online. We make it very easy for people to jump into this category. Okay, so with